Welcome to IB.
Alright, so for today, we are going to discuss about the domain and range of rational function. So let's review. Set of real numbers. So when we say set of real numbers, it includes natural numbers, counting numbers, whole numbers, integers, rational numbers, which are fractions, repeating or terminating decimals, and irrational numbers. For domain, these are the set of all x values, and for the range, these are the set of all y values in a relation. For the degree of polynomial, it is with one variable that is based on the highest exponent. So for example, we have x cubed plus 2x plus 1. The degree is 3y because it is the highest exponent. The degree is 3. Another example, let's say x of 2 plus 2x plus 1. The highest exponent is 2. Therefore, the degree is equal to 2. Okay. The domain and range of rational function. So the domain of the rational function is the set of real numbers except those values of x that will make the denominator 0. Again, the domain of rational function is the set of real numbers except those values of x that will make the denominator 0. So how can we find the domain of a rational function? So the domain of a function consists of the set of real number, or the symbol of real number is big capital R, except the value or values that make the denominator 0. So let's have this example. F of x is equal to 2 all over x plus 1. So let's equate the denominator to 0. X plus 1 is our denominator and equate it to 0. And of course, step 2, we need to solve for the value of x. So x plus 1 is equal to 0. So our x will be negative 1. So with that, we can state the domain. So the domain is all real numbers except negative 1. Or in interval notation, we can write x such that the set of x such that x is an element of real numbers where x is not equal to negative 1. Again, in order to find the domain, we just need to equate the denominator to 0, and that will be your exemption. Again, the domain will be all real numbers except the computed value of x, or except the number that will make the denominator 0. Okay, now let's move on. What about the range. In the range, we have 3 cases. So the first case is when the numerator and denominator have the same degree. So in here, what is the degree of the numerator? Degree of numerator is equal to 2. What about the degree of denominator? Is also 2. So they are equal. So we know that the numerator and denominator is equal. They are equal. So what is our next step? If they are equal, we are going to divide the numerical coefficient of the highest degree terms. So the numerical coefficient is 4 and 2. So we are going to divide them. 4 over 2 is equal to 2. So with that, we can already state the range. So therefore, the range is all real numbers, the symbol of real numbers, except 2. Our interval notation, we can have the set of y such that y is an element of real numbers where y is not equal to 2. Y is equal to 2 again. In the case number 1, in finding the range of rational function, if the degree of numerator and denominator is the same or equal, you are going to get the numerical coefficient, which is, in here we have 4 and 2, and we are going to divide them, and that will be the exemption. All right, now let's move on. For number 2, if the polynomial in the numerator is a lower degree than the denominator, the y value is the exemption. Or the y value 0 will be the exemption. Again, in the case 1, the same numerator and denominator, the same degree of numerator and denominator. That's why we are going to divide the numerical coefficient, and that will be your exemption. But in case number 2, in this case, the exemption will be 0 if the numerator is lower degree than the denominator. Again, we have the degree of numerator is 1. And the degree of denominator is 2, right? So in this case, the numerator is less than the denominator. So therefore, the range is all real numbers, the symbol for real numbers, except 0. Why 0? Because the numerator is less than the denominator. I mean, the degree degree of numerator is less than the degree of denominator. The degree is the highest exponent of a variable in every term. And in interval notation, yeah, I think it's okay like this. Oh, let's okay. Let's proceed with the let's try or set of y such that y is an element of real numbers where y is not equal to 0. Now let's move on. For our last case, if the polynomial in the numerator has a higher degree than the denominator, there is no exemption. So meaning the range is all real numbers. If or y, set of y such that y is an element of real numbers. Ganyan siya. Or, for example, x3, x cubed plus 2x plus 1, and in here, x squared plus 2. So meaning, the degree of numerator is 3, and the degree of denominator is 2. Therefore, the degree of numerator is greater than the degree of denominator. So meaning, there is no exemption. Exception. Okay, now your turn. Would you mind to do this on your notebook and we will check it tomorrow. Goodbye, class.